function? Yeah, we're doing that next. Okay. Geometric, what happens is, gosh, I feel like I shouldn't even spend time on this. We do this all in Algebra 1, but it's a good refresher, I guess. We are multiplying so R is what we call common ratio. If you have the terms and you want to find a common ratio, you can take any term and divide it by the previous term. The explicit formula, do you guys notice, is on this sheet, and so is the recursive. That's for geometric as well. Maybe I don't have explicit recursive. Yeah, there it is. It's kind of in the middle of the page. All right, so if I was doing this one, okay, what's going on here? Yep, common ratio of not 11 but negative 11, right? And first term is what? Negative 1. So the explicit formula for this would be a sub n equals a sub 1, so negative 1, I'm going to use some parentheses because this involves negative numbers, times negative 11 to the n minus 1 power. Why is it n minus 1? Because we didn't multiply by 11 at the first term. We multiplied it by 11 starting at the second term. All right, the recursive. We would write a sub 1 equals negative 1. A sub n equals, you tell me. A sub, how do I write the previous term? It's a sub what? A sub n minus 1, and what am I doing to each previous term? Multiplying by negative 11. Okay, is this coming back to you a little bit? So that was all really review of Algebra 1 and Algebra 2. Let's talk about series. Series, do you see that word series at the top of the paper? Is when you're adding up a sequence. So we should then talk a little bit about summation notation. All right, so in general, summation notation looks like this. And usually we have, I'm going to add k to the mix because I'm using n. So we have k equals 1 to some number n, a sub k. All right, let me talk about what these things stand for, and I hope then when you're developing these they'll make a little more sense. What goes here is the way we generate the terms. So what we're going to put there is going to be an explicit formula. Meaning you'd pick one. If it's arithmetic, it'd be arithmetic. If it's geometric, you use the geometric one. These stand for the term number, okay? So this is beginning term number, and this n is the ending term number. Okay. So I'm going to first have you evaluate one, and then we're going to try to make an equation for one, okay? And that will be where we'll have to stop for today. Alright, so if I were evaluating this, this symbol is a symbol for add up. So this means we're going to add all of the terms from the first term to the fifth term that are generated by this sequence. So let's figure out the first term. To figure out the first term, because this is explicit, we plug in 1. What happens when I plug in 1 to this explicit formula? We get 4. Okay, so this is the first term. I'm going to be putting an addition sign because I'm going to be adding. Now let's put in 2 for the second term. What's 3 times 2 plus 1? 7. 3 for the third term. 4 for the fourth term. And 5 for the fifth term. And then we actually add those things up. Let's see. 4 plus 7 is 11, plus 10 is 21, plus 13 is 34, plus 16 is 50. Okay. Then my last example. Let's write 2 plus 5 plus 8 plus ... 56 in summation notation. Okay. So here's the things that we need for summation notation. We're going to need an explicit formula, which I'm going to find in a second. We're going to need to know what term it ends at. So I'm going to have to figure out which term 36 is, or 56 is. Does that make sense? Okay. So, explicit formula. How about that? Is it arithmetic or geometric? Arithmetic. The first term is 2 plus n minus 1 because I'm using k here. K minus 1 times 3. Are you following what I'm doing here? I'm using the explicit formula for arithmetic. Okay, let's see. Distribute. 3k minus 3. Looks like this formula is 3k minus 1, right? You can use on if that bothers you. In the formula, it uses k because I have a k in it, and because k is where it begins. If that is confusing to you, just use n consistently. That's okay. All right, cool. And I know it starts at the first term. I have this part and I have this part. Now I have to figure out which term 56 is. Would you do that for me? Set 56 equal to the explicit formula and tell me what term it is. Alright, so its summation notation would be k equals 1 to 19, because that was the 19th term. And the explicit formula was 3k minus 1. On Monday, we will talk about